Okay, so Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So hari ini Meda akan explain about the subtopic 2.3 Hess law. So at the end of the lesson, you should be able to know, state the Hess law, apply the Hess law to calculate the enthalpy changes using the algebraic method and energy cycle method. C, you have to illustrate the dissolution process of ionic solid. Okay, so what is a Hess law? So Hess law is when a reactant, okay, converted to the product. Okay, so for example, A becomes C. So the enthalpy change, okay, is same whether the reaction take place in one step or a series of steps. So it means that A become to C. So you can go to, okay, first step directly. So A becomes C is a delta H1, or you can go for series of step, which is A become B and B become C. So they have a two step here. Okay, so if you want to get to delta H1, so it means that delta H2 will clash with delta H3. Okay, so application of the Hess law. Okay, to calculate the enthalpy change of reaction that are too difficult, okay, to carry out directly in calorimeter. So basically, before this, you do a calculation using the calorimeter, but then there are certain cases that you cannot use directly, okay, using the calorimeter. So that one you have to use Hess law, okay, to calculate the enthalpy change. Okay, so there has a two method to calculate delta H. Okay, first is algebraic method. Okay, B is energy cycle method. Okay, so I will explain about the algebraic method first. Okay, so method one, so we go for first example. Okay, example one. So using the algebraic method. So bear in mind, you have to know all these steps. Okay, step 1, you have to know, identify the target equation. So, for example, if the question asks you, calculate the enthalpy formation for this reaction. So, 2 carbon plus H2 will produce 2 C2H2. So, this means that you have to know your target equation. This is our target equation. So, step 2, you have to know, rearrange the equation given. Okay, so you have to manipulate all this equation in order to get the target equation. So step 3, you have to add the equation, okay, to obtain the target equation. Okay, so all the substance must be cancelled. Okay, this one we look at to the example. Okay, the last step you have to know total up, okay, the enthalpy values. Okay, so algebraic method, okay, sorry, we go for the first one. Okay, okay, so first one, you know this is your target equation. So you put your target equation, okay, uh, dekat depan, okay, ataupun dekat atas ni. Okay, so you know this is our formation lah. Okay, definition of formation. Okay, so you want to know from here. Okay, tapi dia bagi a series of okay, enthalpy change. Okay, jadi macam mana you nak buat? So you tengok dekat you punya, dekat sini. Okay, mula-mula kita ada C2H2. Okay, C2H2 is our product. Okay, so you tengok dekat, okay, ini saya panggil first equation, second, third equation. So kat sini produk kita duduk belah kanan. Okay, so kita tengok kita punya this target kita C2H2. C2H2 kita duduk belah kiri, left side. So what we have to do is kita akan first equation kita kena reverse. Okay, you have to reverse the equation. So if you reverse the equation, means that this one you also, okay, negative, you kena reverse juga. So means you akan jadi positive. Okay, so bila reverse, so first one reverse. So you akan buat, okay, 2CO2 gas plus H2O liquid, okay, become C2H2 gas, okay, okay, plus 5/2 O2. Okay, delta H1 equals to first is negative, so bila reverse dia akan jadi positive. Okay, bear in mind. Okay, for second. So you get to the next clue. Okay, if you can see here, carbon here, dia has a 2 carbon. So kalau you tengok dekat sini, carbon kita hanya ada satu sahaja. Okay, 1 carbon. So what does it mean here? So kat sini kita kena darab. Okay, you have to times with 2. Okay, sebab kita nak jadikan dia 2 carbon. Dan kita perlu reverse ke? Tak perlu. Okay, because carbon is also already in the you punya left side. Okay, so you maintain dia punya ni equation dia, delta H dia. So dia still negative lah. Okay, but then you kena darab dengan 2. Semua kena darab 2. Kalau you darab 2, so saya dah bagi tahu delta H pun kena times with 2 lah. Okay, so means that equation tu you have to times 2. So you akan dapat 2 carbon. Okay, make sure phase you kena letak 2 CO2 gas, data H2. Okay, so negative. Okay, bila you darab tu, you akan dapat negative 787 kilojoule. Okay, so how about for number 3? Okay, equation number 3. Okay, so you know that dekat sini target kita ada H2. So kat sini pun ada H2. Okay, kalau yang ada O2 tu, you boleh abaikan dia dulu. Sebab nanti kita boleh, O2 yang tak ada dalam target equation, you boleh abaikan dia. So nanti kita boleh cancel dia punya tu. Okay, kita tengok yang mana ada target kita je. Okay, H2 kita tak ada apa-apa, darab, so you maintain je lah. So equation 3 kita maintain. So tak perlu reverse. So you just copy dia punya tu. Okay, produce H2O liquid. Okay, delta H. Okay, ni 1, H2, H3. So negative 285.9 kilojoule. Okay, so next what we have to do is, okay, you do the straight line. Okay, then you can see here. Okay, what we have to do is, kita akan total up. Yang mana yang sama, kita akan cancel lah. Okay, yang sama, yang mana ada different side, kita boleh cancel. Yang same side, okay, kalau ada yang sama, same side, kita kena tambah. Kalau different, dia bertentang arah. Maksudnya, belah sini left, sini belah right. So, you kena tolak lah. Macam kita pernah buat hari tu. Apa ni? Macam redox equation kan. Okay, so you tahu ada kat sini. Okay, apa yang target kita. So, you tengok target kita, kita petakkan dia supaya senang you nak cari. Okay, lagi yang ada C2H2 kat sini. Okay, so yang lain you kena boleh cancel. So, contohnya yang ni 2CO2 akan cancel with 2CO2. Okay, H2O cancel with H2O. Okay, so okay, you bear in mind 2O2 tambah dengan setengah O2, dia sebenarnya 5/2. Okey, jadi yang ni kita tambah kan, belah same side. Tapi kita akan cancel dengan this one different side. So, jadi semua kita dah cancel. Jadi, kita copy mana kita punya belah rectangle. Kita punya target equation. Okay, so you will produce C2H2 gas. Okay, so you akan, okay, bila jadi macam ni, you akan tambahkan dia. H1, H2, H3. Okay. Okay, you ada dekat sini, so you kena settlekan. Okay, it means that data H1 plus data H2 plus data H3. Okay, we must total up. Okay, bila you total up this one, so you akan buat macam mana? Oh, ini saya tambah lagi sekali. Okay, sebenarnya you letak kat bawah terus pun boleh je, tak ada masalah. Okay, so you letakkan, so you masukkan dia punya value dia. Okay, tambah, okay, make sure negative 787 kilojoule. Okay, lepas tu tambah lagi satu lagi, negative 285.9. Okay. And then when you total up this one, so the final answer you will get positive 226.7. Okay, make sure the final answer, because it's a formation, C2H2, okay, it refers to 1 mole. So, the answer should be kilojoule per mole. Okay, so you can say this is delta H formation untuk C2H2. Okay, so this is your final answer.